right? So you can hardly say what is right, what is wrong, what is good, what is bad. It's hard to categorize anything, but slowly through the years, things are maturing, and so now we have an opportunity to see projects like yours come to fruition, finally from the first descriptions of what blockchain is now to finally make something out of it. And so this course is general one. We have students from very different backgrounds. Some are developers, some are more business oriented, some are very young still, quite fresh, but others, some are even retired already, have PhDs on their own. So it's quite a diverse group. So I expect that it would be educational for a lot of them, for me as well, of course.
Oh, that's good. That's good. So that's why we have like the slide deck. Actually, it's kind of like a mix of technical side and non-technical side of IoTeX, right? Because we do see like probably some people will be very like usually enthusiastic about the technology, but some will probably be more passionate about the applications, use case, IoT, blockchain, like in general. Yeah. So how's this cryptocurrency market like overall in Cyprus? Is it something like pretty new, or it's pretty like everybody's so educated?
You mean in Cyprus?
Yeah, I mean in your country, how's the Bitcoin, Ethereum, everything else?
Yeah, as far as I know, Cyprus is quite reserved to. I mean the use cases are not that well developed, and you actually can't pay a lot of things with cryptos. But Cyprus is more known for its trading community, so trading platforms and investors are more likely to be found there. But since this course is actually a distance learning, we get students from all around the world. So I don't think there's many of them from Cyprus at all.
I see. But generally, like, where are they based? All in the Asian, Europe?
Mostly from Europe, yeah, but some from Middle East, not so much from Asia. I actually moved from Europe to Malaysia just 2 months ago to be closer to this space because it's so much happening here. I'm sure you know Singapore is quite active as it could be. Yeah, so it's interesting. Yeah, you are in Silicon Valley, right?
Yeah, like the entire team is here. We have like a very small sub team in Asia, a very small sub team in Russia. Yeah, Singapore, they have some events going on, like last month, it's Consensus, right?
Yeah.
IoTeX team was there for that event.
Nice.
Yeah.
So how come did you choose Silicon Valley instead of staying here, maybe?
Oh, yeah, that's a long story. Basically, I studied in Canada, right? And then after graduation, yeah, because Silicon Valley is like the heaven for technologists, right? For developers, for engineers, for researchers. So that's basically like a no-brainer for me to come here. And first, like my first job is more like a security engineering at Google. Stayed there for a couple of years, and then Uber, and then like this blockchain thing, and like I just can't wait, right? So that's why we have IoTeX with 2 other co-founders.
Right. So from the website that I've seen, you have a really strong team. They're one of the strongest that's available. So many experts coming together. That's a rare sight.
Yeah, that's a very rare actually. When we were doing some other events yesterday, we realized we have 7 PhDs, all from top universities, globally, some from Singapore, US, Canada, Waterloo, also here, Harvard, MIT, 7 PhDs in a team. That's like phenomenal.
So expectations from you are pretty high, I guess.
Yeah, we are. Actually, we have also high bar for ourselves when deliver products, when design protocols, right? We also have high bars. We don't want like go out there just like shouting to the world. We are doing something like crazy, big, important, but actually we want to show the real things to the world, like we are what we're. Yeah.
Great, excellent. Well, fingers crossed for you. So I guess we are pretty much ready to go.
Sure.
It's a couple of minutes over.
Yeah. So I can just go ahead to get it started.
Yeah.
Sure. Let me do this presentation. So yeah. So cool. Let's get everything started. So thanks for Gregor for the invitation. So basically, Zhijie and me will go through some of the IoTeX technologies in this session. So in general, like IoTeX is building out of scalable and privacy-centric decentralized infrastructure for IoT. So the agenda, we're going to talk about different things today. Some are tech, some are non-tech, because we have like a mix of people from different backgrounds. So first, I will talk about the introduction, like what we're building, what is IoT, what is blockchain, and why do we put these two together, and how is IoTeX different from other IoT plus blockchain projects, for example, IOTA and other things. And then Zhijie will dive into like IoTeX architecture, like how this blockchain looks like internally. And especially he will deep dive into the role depots, like how's the design going on, and why do we choose this design, and what's the rationale behind this. Then the next one will be like a more engineer and technical focus is how do we do this testnet development? How do we like try to run like even hundreds, even thousands of nodes in a testing environment to make sure like everything is scalable, reliable, and efficient. And then privacy, I will roughly talk something about privacy. Privacy is such a thing like that ties to the cryptography so closely, so I'm not going to talk about too deep in privacy, but I will try to focus on like one invention we have is like a lightweight steel address. Then there are some like a couple of slides talking about the team, like the everything general. So if we have time, I'll talk about that. If we don't have time, we can skip on that. All right. So I assume we're good. Yeah, so just want to check, like everybody's good. Okay, no questions so far. Yeah, so Gregor, feel free to interrupt me if anybody has any questions to ask. Yeah, I do want this session to be like more interactive. Yeah, because when I do this like a present, I cannot see you guys on the sidebar, so I can only see myself. Yeah. Okay. So IoT market could be like a trillion or like even like a multi-trillion dollar market in the year coming along. So there is some expectation like by the year of 2022, there will be 80 million devices that is actually connected with each other. So in general, like people thinking there will be 9 typical settings for the IoT market. Could be like a smart home, smart office, smart factory, some retail environment, manufacturing, cities, and human transportation, so on and so forth. In general, like IoT market is something people have been thinking of for a while, but like it hasn't taken off yet. But like people also have a very high expectation for this market. So that makes us think like why this IoT industry hasn't been taking off yet, right? Because we see like smart speakers this year's very good smartphones from China, from Apple, from other countries, but still like this like just like a tip of an iceberg. Like the entire industry is not taking off yet. So that makes us think why. So our rationale is to take off this industry, we need like a wider adoption of the IoT devices and applications, which actually relies on reduce the cost of the devices, also have some killer applications. Of course, these two things depends on other things, for example, like great ideas, right? Or maybe some like advancement of hardware technology. But there is like one common thing like these two are based on is like infrastructure underlying. So we're thinking about we should have like an open and neutral infrastructure that can be accessed by all the devices globally, and also provide this interoperability to millions of devices without like any trusting issue. So the model we see so far is basically Amazon. They will have like their own cloud, and their like IoT devices will talk to their cloud, interact with each other, and probably Amazon will have another basically like an island of IoT devices. But by putting this all these like isolated islands together, we can have like a more unified infrastructure for all the devices. Then there will be like a more values by having this IoT devices interact with each other, which are not within the same island. So that's like the reason we believe blockchain and IoT, they are like a natural fit with each other. So in that case, this open infra could be like a blockchain, and could be something else, which we probably don't know yet. So this blockchain can provide this decentralization, scalability, and security. It's promising because of these three properties it can provide. In terms of decentralization, it can make sure like no one just controls every device right on the world. Because we don't want Google controls everything for you, Amazon controls everything for you. We want to have something like people can trust without having them to control everything of us. And also scalability and means to see is very important because we're talking about millions or even thousands of millions of devices talking with each other. Right? Security also is very important because we don't want someone to take down an entire infrastructure and control all the devices in the world, which is like a kind of Skynet, which we don't want to happen. Of course, security is very important. So then that's why like we are looking at the blockchain. We're saying, okay, blockchain makes sense, but what type of blockchain are we looking at? So that's why I have this table. So there are some like properties like the IoT applications they desire, but the existing blockchain they cannot provide. So for example, like a heterogeneity, that means the IoT device is so different in software, hardware, even like communication, fundamental purpose, everything else. While the blockchain is basically designed for homogeneity devices and applications, at least in the Bitcoin and Ethereum cases, right? So that's one. And secondly is like a scalability. Like as I mentioned, we were talking about 18 billion of IoT nodes by 2012. However, like a scalability issue for the blockchain is such an in-progress thing. So we have better consensus ongoing, sharding ongoing, everything's ongoing, but we are not there yet. And most importantly is privacy. Once we have everything talking with each other, the privacy becomes a real deal because you cannot rely on something that basically exposes everything about other people, right? So we need privacy in this case. However, like privacy on blockchain is still like at a very, I would say like infant stage right now. So that's why we have this like IoTeX idea starting from last year. Actually, we were planning this starting from April last year, and the entire project kick-started around June. And then we have the fundraising and everything done by end of last year, where we start to grow the team this year. We now have 15 full-time employees in Silicon Valley office and a few in China, actually Shenzhen, like we are doing more hardware kind of stuff. And also we have some community satellite office around the world. So IoTeX basically has 4 innovations. We have like a fast consensus, which is called road depots. Zhijie will dive into that. And also we have some blockchain architecture. I think Zhijie will also talk about that, so I'm going to ignore the details from here. And the privacy preserving technology is really the thing we want to focus on, especially make it lightweight enough so every other device could use, right? And then autonomous device coordination is like the goal for this project. So I would say like similar as Ethereum, IoTeX kingdom or universe or ecosystem still has 3 layers. We want to have like this first layer to be like an IoTeX blockchain, especially the root chain. Then we'll have the second layer as the subchains. I think probably in the next few minutes we will explain what subchain is. Subchain and which builds on top of the root chain provides some more concreted services to the user. Then there will be like a third layer, which will be a DApp layer, they were built on top of sidechains to provide like a very even more concrete application or purposes. So like the things we're thinking about is sharing economy. For example, we have a partnership which is like basically offered in China. It's a bike sharing company. They want to do the sharing bike, everything like which has a blockchain as a backend. Also, smart home is another scenario we want to target to, and as of course industrial IoT, where like this becomes even more important because given like a scale and the mission critical nature of this IoT devices in the industrial world.
Are you also doing anything with the hardware itself, with infrastructure technology as in physical sense?
Yes, we're. Actually, I will cover that in next slide.
Okay.
So like here's like a smart home demo. We are having this demo for the CES January in the coming January in Las Vegas. It's pretty simple. Like we have devices coordinate with each other based on our blockchain. So this, as you can see, this picture is basically showing like a smart home. We have different like a smart door, smart light bulb, some thermostats, everything. Like they can talking with each other in a trustless way because they have blockchain as a backend. On the right side, you can probably see the video. This is the prototype we did. It's basically we send a command to change the states on the blockchain, and the device will try to fetch like the latest status from the blockchain and try to match its own status with the blockchain status, right? So that's why in that case it says, please open the door to the blockchain, and later this IoT device says, okay, I should be open, so I'm going to just run myself. Yeah, I know it's like a dummy demo, but it looks very cute.
Mm-hmm.
Yeah. Okay. So talking about like what we are doing, right? Like we have a bunch of people. Like I said, even like probably roughly half of the team is PhD from top universities. What we have been doing so far. So basically for this year, we want to have this testnet complete. We are taking almost 1 year to build a testnet because we are doing everything from scratch. We don't want fork code because we do want have like a brand new design and implementation of the blockchain by ourselves. So that's what we have been doing is testnet. So we want to have like most of the features for the testnet to be done by end of this year. That's one. And second is like for the next 6 months, starting from next year, we want to launch the mainnet, where is which means like a root chain, and we want to like map our tokens, or the ERC20 token, to the native coin, right? So once that is done, we want to launch our first subchain. Actually, you probably depends on our engineer process, but probably people could be able to see like the first subchain in the IoTeX world, even after our November's launch in the testnet, because we want to launch the first subchain that's really targets on the privacy. So that's the goal. And then for the even next 6 months, start from Q3 next year, we want to do something called IoT Hub. The idea is very simple. We want to have like provide SDKs, some even hardware like connecting points to have devices to be able to easily and securely connect to the IoTeX blockchain. And this could also means reliable and also secure, and support like a million of messages and billion of devices. So that's a very ambitious goal actually. And once we have that part done, then we can build like this IoT Oracle. Because as you may know, Oracle has been like a really challenging thing in the blockchain world. Because like a blockchain is really like a very isolated world. It's like a walled garden, right? Without knowing any external information. Everything is like so self-contained. So that's why like blockchain is basically not so useful as of time being. But once we have all the devices connected to our blockchain, then there is some chance like we can have like them to provide data, and which forms like an oracle, and also this oracle information can be used by smart contracts on IoTeX blockchain, and also maybe this oracle can be used by even other public blockchains. So that's a goal for 2020. Okay, so I think for the introduction, probably the last slide I will have is a comparison. I got a question from Gregor before the course is like people are asking, so what is the difference between your consensus at the DAG and IoTeX between other IoT projects? So I would say like at a vision level, every IoT plus blockchain projects they're different. Actually, I learned a new word. They call it a BIOT, B-I-O-T, which means blockchain plus IoT. So yeah. Uh, so every project has different version. Like our version is like we just be the platform that provides interoperability for devices, right? While IoT is mostly focused on this M2M transaction for now, and RAF, I think RAF, no, actually ITC is like IoT clone in China. It's by like a small team. They're doing almost the same thing. RAF is another like a IoT plus blockchain project, but like they are all like more concrete on one kind of application. It's basically setting like a solar power or something like that, as far as I know. And IoT, I think it's also like doing something which is not there is no much transparency. So in terms of like consensus, we are doing this hierarchical blockchains while IOTA is having this DAG okay, I'm not trying to pronounce that word, but that also means they are doing a stack at a transaction level. I think that's a great idea for some of the applications because it's super fast, also very lightweight. But the problem is like there's no global consensus, right? So if there's no global consensus, you cannot do smart contract. You cannot do like this coordination of devices. I think that's the most important problem. I also have some recent efforts, like they are trying to set up some like a very centralized server called a coordinator. Then everybody in terms to in order to get this global consensus, will try to talk with this centralized server. Then they are basically screwed up in terms of decentralization. So that's why I think this DAG at the transaction level may not make sense to what we're doing to what our vision is. So that's basically simply put. Yeah. And also privacy is another thing like we are really differentiated from IoT and other IoT plus blockchain projects. Yeah.
So based on that, you don't have that much competition out there, do you?
For competition for what?
I mean, if IOTA is understood as being for M2M transactions for payments, but and others being more obscure, then there is not that much of projects out there. I mean, if you just go with regular blockchain, there's everyone announced every week.
Yeah. You're right, actually. Actually, when we are attending events, we also keep like our eyes open and talking with other blockchain and IoT projects. And luckily, like most of them become our clients, right? Because they are usually working on a very specific vertical in the IoT space. For example, like there is a I think some project called Tanko in Korean, Seoul. So they are building this supply chain very concretely. So they are doing this on Ethereum. Then we just go there, actually me just going there saying, Ethereum is too slow, too expensive. How about you guys building on this on IoTeX, which gave you like a free platform you can use. Okay, then they are very happy about that. Yeah. So like we don't see many like IoT plus blockchain infra level projects so far. So you're right. Not so many competitors here.
There's a question from Alejandro.
Okay.
Hi, Raullen, one question. With so many consortiums working in supply chain initiatives, how you see IoTeX interacting with them? What about interacting with Beta, IBM, Hyperledger, Sawtooth, and EEA?
Yeah. So I would think like the public blockchain and the consortium blockchain, they are totally different groups, right? Like for like big companies like IBM, or they will be very interested in the consortium blockchain because they do have the resource to build everything from scratch. That's good. But as we see, like the example I just gave, is we see for like a medium to small businesses, they want to do supply chain management on top of blockchain. They usually don't have this power or energy resource or engineering resource to do everything by themselves. Then they are more like a trusted kind of public blockchain in that sense.
Okay.
Yeah.
Are you a member of Trusted IoT Alliance, or are you thinking of becoming?
Oh yeah, we are actually invited to join Trusted IoT Alliance. I think maybe 2 months back. Yes, we are on the alliance or already. Yeah.
Okay. Any other questions, guys?
Okay, so I guess we can move on to section 2, where Zhijie will talk about this IoTeX architecture, which is very technical heavy. Be prepared.
Hi everyone, this is Zhijie from IoTeX. So from this section going on, we are going to focus more on the technical part. So in this section, I'm going to introduce our IoTeX blockchain system. Because of the limit of the time, so I still could be able to doing some very high level introduction, and we'll talk about, by introducing our blockchain, we also involved some common blockchain technologies as a reference, and tell you guys about our rationale behind choosing this technology over that technology, for example. So first, let's take a look at what is going to be the essential components for the blockchain. There are 3 things we summarize as going to be the necessary piece. The first is going to be the ledger. The ledger is some piece of the data a node need to keep, and we are going to write into this ledger to record what happens in the world, right? The other necessary piece is the peer-to-peer networks. This enables different nodes to be able to talk to each other. So they can share the exchange of data, they can coordinate things, and the third necessary piece is the consensus. What consensus basically want to do is to make all the nodes to agree on doing the same thing. For example, everybody is going to agree on write the same transactions on each ledgers on each node. So given these 3 pieces of components, the blockchain is able to work. But in the many modern blockchain systems, we also have the smart contract, because people feel that blockchain, the decentralized trust, is enabling not just the money transfer. We can basically do many other things. The smart contract gives people the freedom to define the arbitrary computation logic on top of the blockchain data. So in the next few slides, we'll go through these pieces one by one, because all of the appears in our architecture. So this is the diagram we put from our project repo, and it is no surprise that show that we have all these components. For example, the state factory blockchain and the state block DBs are our ledger parts, and we have the peer-to-peer networks implemented. We have the consensus model. We have the virtual machine. In addition to these 4 pieces we have mentioned above, in our systems, we also build something additionally to make it could work more practically. The one is the action pool. This is a place we cache the transaction that hasn't been processed by each node, and we have the block sync to make each node be able to catch up the missing blocks, because the different nodes can join in the network in different periods, and they may missing part of the information in the network already. Also, we have the dispatcher. That sounds like some coordinator of the whole system, and they try to dispatch the workloads into different pieces, components, to make them work together. Okay, so then let's go through all the components one by one. The first one I wanted to talk about the ledger. This is some charts I borrowed from some other slides talking about the data structure of the blockchain. at high level, the blockchain is the block linked list, and block header has some metadata information. Some important one like the previous hash, which is pointing to the hash of a previous block. This is a very critical piece to make sure if we want to manipulate the data in one block, then you have to modify all the blocks afterwards. So the cost of manipulating the blockchain is going to be very expensive. And in the body of a block, there's just a collection of the transactions, and all the transactions will be organized in the Merkle tree, and the Merkle root is the hash put into the blocks for the quick verification of the data correctness. We implemented according to this data schema because it's pretty standard for the blockchain. In addition to this block data tells us what happens to what happens in the world, right? And the other things we wanted to keep track on is what is current status of the world. So in blockchain, there's two kind of accounting technologies to do this. One is UTXO, which stands for the unspent transaction output. Bitcoin uses this kind of accounting models. So in this one, what the system actually tracks. Sorry, let me put. Doesn't matter. So this kind of accounting models, we actually going to keep track of all the unspent transaction outputs at any stage. For example, in this example, we have the 1 BTC, 40 BTC, and the 0.5 BTC in each different UTXOs, and if the transaction is actually collecting the UTXOs and from one address, and then generate another UTXO into another address. This is the how this accounting models works in Bitcoin and as a UTXO. And another way of, by the way, I should mention that the merit of doing this is there's a scalability, because you are able to process the two transactions in parallel if you are able to involve completely independent UTXOs, even they are coming from the same address. On the other side, the Ethereum choose to use the account model because this is much easier to manage the status of each address. For example, you will have the balance in count full, and you have balance in count bar. The transaction happens is moving from 30 ETH from full to bar, and you just need to update the balance in each address. So in this way, we can have a very efficient and very simple implementations, and also in terms of storage. So another reason for doing this account-based things is Ethereum you need to support the smart contract, and we also would like to support the smart contract. So in the smart contract, the assumption is more relaxed. The data you keep is not just some money. So the UTXO is more money-oriented accounting models, and we wanted to have a more generic one so that it can be able to keep some data like what is the temperature has been measured from the thermostat, right? And last but not least, the things for all the data we have mentioned, we put this into our key value store, which is the DB. Yeah. Okay. We finished about the ledger part. Let's move on to the peer-to-peer networks. And because this blockchain is a decentralized networks, people have the nature of talking to each other. So traditionally in the centralized mode, every client connecting to the servers to exchange the messages. But well, for the blockchains, we need to make every node be able to talk the other nodes in the network. Again, for the P2P networks, there's two kind of implementation category. One is called the unstructured P2P networks. The unstructured P2P networks makes every peer to randomly pull some peer list from, for example, some node tracker from the DNS, and connecting to them for exchanging the message. Bitcoin adopt this kind of peer-to-peer networks. The merit of doing this is it's easy to implement, and this unstructured topology is more tolerant to the network churn, which means that when peers leave, it is going to be very quickly to adapt it to the new situation. Also, it's going to be more secure because you cannot predict who is going to be my neighbors. This needs to be compared to the structured peer-to-peer networks. In a very high level, that means that we follow some algorithm for some certain schema to define the graph topology and for something like the DHT. Ethereum uses one. This structured peer-to-peer networks. The merit of doing this is more predictable latencies because every node has some routing table backed by the algorithm, and you have guarantee on in how many steps you are going to be reached. This is the good part of this, but because of this structure, that you can predict who are going to be your neighbors. So, sometimes ago, there are some researchers has make the eclipse attack against the Ethereum node, which basically means for a node, I can try to pretend create a lot of malicious nodes to surround you because I know in which way that I could be chosen as your neighbors, so that node will be isolated from the rest of the network. Yeah, as Raullen mentioned, we optimize it towards the security, so what we would like to choose here is to use the unstructured peer-to-peer networks to prevent such kind of eclipse attack. The next one is smart contract. As I mentioned before, smart contract has enabled the blockchain to do the things more than the money transfer. So we focus on the IoT use cases. What we would like to enable is for the devices be able to exchange data. So that is why we need to build our smart contract solution on top of a blockchain. So Ethereum, even if it's not the first, but maybe the most successful blockchains, has built up the smart contract support, so that the developers can develop the D apps and run against the blockchain system. So normally from the front end part, the D app is very similar to the classic application, but the different part is that it uses the Web3.js library to talk to the smart contract that deployed on the Ethereum nodes and being run by the Ethereum virtual machine. In this way, your data is going to be run, executed, and read is not going to be backed by any centralized service like the Amazon Cloud, the Google Cloud, for example. It is backed by the Ethereum, backed by the blockchain data. So we choose to support the EVM on the IoTeX blockchain because for two reasons. One reason is we think compared to other ongoing virtual machine technology like the WebAssembly, V8 engine, LLVM, for example, this the EVM has been proven successful in production in blockchain for a very long time. And the others is we have already people that the whole community has already built up a lot of the apps based on the Stability, which is the programming language supported on the EVM. So if we support this kind of smart contract ecosystem, we can easily migrate existing DApps into our blockchain. Yeah. So some very quick examples about how the Stability the contract written in the Stability code. If you are not familiar with this one, is very simple contract to define a token, and you can also allow people to do the transfers between each others. A more extensive and comprehensive version of this smart contract it is ERC20 token contract. You'll probably be familiar with if you have participated in any kind of ICOs before. So let's go into a little deeper into the smart contract, into the Ethereum virtual machine to see how it works in essentially. So in this EVM, it contains actually two parts. One is the non-volatile part, where is your Stability code, but it's compiled into the bytecode already, and also the storage. This is the data that has been computed by this smart contract and put into the disk. And the other part is called the volatile part. And in the volatile part, basically it just has one stack that is going to use it to compute your code, and have the memory that is a place to host your data that is using the current working set, and some arguments that configure the whole virtual machine to work. And for the right side, this is an example of how this stack is working. We put the bytecode and the data will be pushed into this stack one by one. For them, push the 98 data into the stack, and push the 12, and push the 45, and then push the operand plus. Then this plus operand will fetch two values from the stack and do the calculation and put the data back into the stack, and so on and so forth. This is how this EVM is working. So this is like I mentioned, this is a well established virtual machine technology and smart contract technology, and Ethereum's community is also exploring some new smart contract and virtual machine based on the WASM, and we are also closely following this technology trend. Other than these three pieces, the one that I would like to dive a little deep into is our consensus, which is called Raullen Chain. But let's take a step back. Let's try to summarize all the kind of consensus that are available in this blockchain. There's a proof of work. Bitcoin, the Ethereum is doing this right now. They basically use your computation power to compute the hash and resolve this puzzle to to judge who is going to be the block producer, and the other one is proof of stake. It's who going to propose the block is determined by the how much stake, how much tokens you own for this blockchain. Ethereum, the Casper project is trying to do this, and Ethereum will eventually move to this direction. And there are some delegated proof of stake. EOS is on this track. Only a short list of block producers will be chosen to do the block producing. And there's a proof of authority. There's Byzantine fault tolerance. With this one, I will explain in a little more details later. So our consensus is a kind of a hybrid of the delegated proof of stake and the Byzantine fault tolerance. This is the chart for our consensus overview. Let me try to explain this piece by piece. First, let's try to expose why this is called the depots. So, in IoTeX blockchains, we have the voting systems. So, if you have you own the token in this blockchain, you should be able to nominate yourself. Say you want to be the block producer, right? And other people can vote for you. So the total number of stake you are going to have, and to judge whether you are qualified for the block producer is the tokens you own and the tokens the people who vote you own. So we will have this voting system to manage the voting, self-nomination, the voting, and eventually we are going to sort all the people's the self-nominators according to the stakes they have, and choose the top 101 to get into the candidate pool. So this is why we are the depots. Okay, then let's talk about what roaming. This is most awesome part for our consensus. So compared to the EOS, which always make the top of the candidate list to do the block producing, we would like to increase some randomization, because that is going to help us to involve more people to more block producers into our blockchain. For example, we can have the 101 pool, right? And this also prevents that if a group of people want to do bad things, they cannot do this forever. So one concept I wanted to introduce here is we have divide the whole blockchain into a number of epochs. Each epoch you can think of is a list, some certain number of blocks. Let's say it's 100, and for every epoch, we will choose 21 delegates that is going to be responsible for producing the blocks for this epoch one by one. And once the epoch finished, another group of people will be chosen. So how we're going to make every epoch to choose different people, even if the candidate pool is pretty stable, because this is going to be expected. Usually the top token holders will not change too much over the time. That part is our cryptography sorting. We use some crypto sort and take the seed as input, take the apple height as input, so that if these two parameters has been changed over the epoch, then we are going to select another completely arbitrary delegate for the next round. So you can see for these things we need a seed. This seed need to be not predictable, but because if the seed is predictable, epoch number is also well predictable, so people can predict who is going to be the next epoch's block producer, right? So how to keep the seed not predictable is a very key technology for our blockchain. What we do is in every epoch, the delegates will do the block producing. That's the ordinary duty for them. In addition to that, they will do some distributed key generation, which is called DKG, and everybody will agree and grab some private secret key share and use this to do the BLS threshold signature. And this signature will be used as input to generate the next epoch seed. So this guarantees things until the end of this epoch, you are not able to determine what seed will be generated. Also, this seed is generated by one person, but by all the participants in this epoch's block producing. So that cannot be manipulated by just an individual party. Okay, so yeah, this is how the whole consensus is working. For each round of the block producing in one epoch, we run the Byzantine fault tolerance algorithm to make them agree on a block committing. I will explain this a little later, but before we reach that, I want to raise one question to you if you are still not aware of that. In this consensus, for the first round, there's some tricky part because for the first epoch, we don't have delegates has been elected already, right? So there's some way to work around. We can take this first epoch's delegated election just off the system. One option is to doing this on Ethereum. We could create a smart contract before we launch the mainnet, and we can use the we can collect the results from the Ethereum smart contract voting and put this as the elected 101 candidate as the delegate candidate in our Genesis block. So this is how we kick off the Raullen Post consensus from the very beginning. Okay, so let's go to the single round of block producing. We use the Byzantine fault tolerance algorithm. This is a very well discussed, well studied consensus method, and which helps us to reach the block finality immediately. That means once the good nodes, for example, there's a 2/3 plus 1 node in the delegate pool has agreed on a block, then this block will never be reverted. This is a very good property of this consensus, because that means once a block has been confirmed, your transaction is confirmed. Unlike the Bitcoins, for example, you need to wait for 6 blocks to have enough probability to say your transaction is being confirmed and will not be reverted. That enables us to do a lot of quick transactions that to power the IoT use cases. We basically follow the practical Byzantine fault tolerance research paper to implement this consensus code. But we do some simplification because based on our assumptions. So first, we don't have the request stage because every delegator will have its own time slot to raise and propose a block, so that is self-initiated. And then the other is the reply. Also, we don't need to have everybody to reply the client once they do the local committing of the block. So we have the broadcast the protocol to make sure that your local block committing will be broadcasted to everybody. So in our implementation, we will have just 3 steps. The first is as a proposer will propose a blocks, mint the block and put the transaction into this block and send to others. Others will validate if this is the correct one and make its endorsement by the signature. And then every node will check in the network. I have received 2/3 plus 1 signatures on this block. Then I know this is a good block. Then we should good to commit. Yep. Okay, so this is the basic what our blockchain is doing. In the presentation before, that I have involved some charts that has been borrowed from this list of the links. So this is also good readings if you want to learn more about the blockchain overall. Our project is already open source. It's on the GitHub and /IoTeX project /IoTeX code. The code is written in Golang. Raullen also mentioned that we build everything from scratch. So if you are interested in our blockchain project, just feel free to reach us. And you can this is my email. You feel free to just shoot me emails, and we are very welcome to your contributions. Any questions so far?
Just 2 quick ones. So one was, are you also interested in building devices, or are you purely a software-based company?
Oh yeah, so we are kind of a hybrid companies. We so this blockchain system is more software oriented. We build this blockchain protocol so that we will have the eventually deploy a group of the servers to operate the blockchain and to produce and process the transactions. But we also need to build the clients, right? We need to build the blockchain client into the different kind of devices and make this device be able to interact with the blockchain. So in this part, we also have the embedded system engineers. They are developing all the hardwares. But we currently are still not manufacturing, building our own hardwares. We do a partnership with other companies, with other projects.
Understood. So there were another question. So the devices themselves won't run this computationally heavy consensus algorithm, etc. They are basically just providing data and maybe do some little things with it, but there will be other kinds of blockchain clients or nodes that will do the heavier processing.
Yeah, we imaged in the IoT use cases, the whole system is going to be heterogeneous. The device is usually very have limited computation power, so they need to dedicate the computation into the more powerful one. But there's still some edge computation they need to do. For example, how do they trust the data they collect from the blockchain network is correct or not, right? This is there's still kind of some verification they need to do, but we will differentiate the role and depending on the role and make some suitable computation on it.
A question: since it is a sophisticated consensus designed to be secure and fast, how faster is then proof of work or proof of stake? Just some basically range of what you are targeting, maybe.
Yeah, so proof of work like the Bitcoin and the Ethereum, if I remember correctly, for Bitcoin they cannot reach the 10 seconds. They cannot reach 10 seconds per second. And for Ethereum, it's a little faster, between the 10 to 20. I don't remember the exact number. And for us, we have some internal workload test, and so based on our the metrics we collect so far, we can use our consensus, we can reach as fast as the 1,000 transactions per second.
Mm.
Yes.
And do you have any idea of how many devices you would be able to support?
I don't think this will going to be some hard limit. So because it's not limited to the number of devices. It's limited how many traffic, how many transaction has been put into this system, right? So this is sort of by the TPS, the how fast, how efficient this consensus is. But you know what? This is just the layer 1 technology, and we are also doing the side chain protocol, and this is still under development. So I'm not sure I could touch too much details today. But in general, we are trying to build some subchain that can hook into the root chain and use the root chain security trust to back up it. But on the side chains, you can run even faster consensus. You can even use some dedicated server to do the block producing, right? So that could be much faster, and this also migrate the workload from the main chain to the side chain. So I would like to say depends on the use case. We will choose if we need to continue to scale our system in terms of the transaction throughput. Otherwise, so I think at the very beginning, the current consensus should be fast enough.
Okay, great.
Okay, so next I'm going to talk about the IoTeX testnet deployment. Are we already run over time?
I haven't gotten the message that we need to finish, so probably we have a couple of minutes.
Okay, yeah, let me try to wrap up this part very quickly, because I think Raullen also have some other awesome things we want to share with you guys.
Oh, okay, great.
So we have built this blockchain technology. We also need to validate our blockchain is working properly before shipping it, right? So in this way, we're not like the one who joined in the one blockchain network and start one node. What we want to do is start hundreds or even thousands of nodes altogether and managed by us. This is a very, very tough work. So to make this happen, we use the Docker to containerize our blockchain code so that easy to be deployed on the Linux system, and we use Kubernetes to coordinate the deployment on hundreds of thousands of machines, and we use Kibana to basically keep tracking the logs, do the aggregation of the logs and tracking the logs online, and we use Prometheus, which is a metrics collecting system. To collecting the system metrics. So by deploying all these tools, we are able to set up our testnet and manage and monitoring its healthiness and the performance, etc., etc. So the whole deployment architecture is like this, right? We have the Kubernetes class manager. It downloads our blockchain Docker image. It downloads the key pairs we feed into, download the config template. It will try to start the Bootstrap node, which is the place people will first connect into and know other nodes in this system. And we will start a bunch of real blockchain nodes to do the block producing, and they will talk to each other, they run consensus and pick actions and committed blocks. And we also have a workload injector. This is not part of some real blockchain, but we need to inject some test workloads, which is some artificial transactions, votings, smart contract executions into the blockchain to verify it can handle this transaction correctly. And one thing we need to I need to point out is for the Bootstrap node, it will connect into the one persistent volume so that the blockchain data has persisted on the Bootstrap node is even going to be kept when the Docker containers lifecycle has been completed, and this data will be put into some backup like the S3. And if anytime we want to upgrade our blockchain, or if there's a bug, the blockchain crashes, we could restart by pulling the data and start from the previous crashing or stopping checkpoint. So yeah, based on this, all this magic happened behind, we built up our testnet. The URL is IoTeX scan.io. This is the front end page. Look how the front end page looks like. If you are interested in, just go ahead to visit our web page. And we in the last testnet beta release, we have also enable our wallet service, so you can go to this wallet to get a test account, get some test tokens, play with it, and even play with the smart contract. Okay, cool. So for this part, any questions?
No questions for this moment.
So we're good, right?
Yeah.
Okay. Okay. Cool. So give me 1 second. I think Raullen has something else outside. Let me ping him and put him back to continue to the next part. Okay.
Oh, sure.
Yeah.
Hi. I guess we're running out of time. Do we still have time to go through privacy, everything?
Maybe quickly. I didn't get the message that we need to end. So when I get the message, we will have 2-3 minutes still. So.
Yeah. Okay. Yeah. All right, guys. So I will be brief about the privacy. Since it's like a very hardcore cryptography, so there's lots of things like we cannot dive into given this time limitation.
Yeah.
So basically, like the privacy technology that is used in blockchain. So here are like a 4 mainstream. Actually, there are 5, but only 4 on this table. So MTC, multi-party computation. The idea is like basically we have like a few people, we can work together, work on something, like compute something, but like each of us don't know like what we're doing. But collectively, we will compute something very meaningful. So that's called MPC. The problem is it's very slow. It's also like it's any practical among just few people, maybe 3-4 people. So basically, the purpose is do privacy preserving computation, but MPC is one of the ways. Another way is called FHE, that is fully homomorphic encryption. So that sounds like impossible. Basically, you want encrypt A to be like a ciphertext A, encrypt B to be ciphertext B. Then you want perform some type of computation on ciphertext A and ciphertext B, and get ciphertext C, right? We'll decrypt ciphertext A back to C. Then C is like a very meaningful result. Basically, it's equivalent to the computation from computation on top of A and B. So that sounds like something possible. So that's a very, very slow progressing on the theoretic side, so not practical at all at this moment. ZK. So ZKP is practical, although it's slow. The idea is basically I prove to you like I'm rich enough, I can buy like a whole building, right? For example, without telling you how much I have. That also sounds contradicting, but that's true. There is some way to construct this mathematical proof, and like some people can verify. So okay, that proof is true. So you are rich enough. Yes. Zcash uses this technology. we also use some of this ZKP technology trying to prove like the privacy preserving computation is right. Last one is called TEE. Like the idea is, for example, Intel SGX, like you have hardware secure enclave. It's like a safe box, right? Like no one can tap into. And you put your like encrypted thing into the safe box, it will decrypt within the safe box and do all type of computation. And when it's done, when it gets out of the safe box, it gets encrypted again. So no one knows what is going on inside. But this is guaranteed by this hardware. Another one, which I didn't list here, is like a ring signature plus confidential transaction. So basically what we are doing is more on the trusted hardware plus ring signature plus confidential transaction. We haven't finalized the protocol on the in terms of privacy yet, but that's basically the direction we are progressing into.
How are you comfortable? Are these technologies already mature enough to be used already?
No, I think everything in privacy field is pretty infant. That's pretty, yeah, it's still like a work in progress. But that's where the opportunity is. I feel like the scalability work is close to be done, maybe 70, 80% down. But for the privacy kind of work, it's only like a 20%, 20%. Yeah, it's just get started. Yeah. So one roughly mentioned is still address protocol. So basically, in a confidential transaction, you want to hide three things, right? Sender, receiver, and amount. Yeah, without concerning about smart contract. Like let's say just A send $10 to B, then you want to hide A, B, and $10, right? That's the purpose. And they use three different technicals to hide three of those. That's very cumbersome, but that's the truth. So for hiding this receiver, there's something called the stealth address, which is like the protocol I listed here. Like with this one, you can hide who's receiving your money. With like another protocol, which is called bulletproof, you can hide the amount. And with like a coin mix or maybe ring signature, you can hide who's this money coming from. So that's the idea. So for the stealth address, which is used by Monero and other Bitcoin protocols, it's pretty heavy. That means like the receiver has to like scan the entire transaction blockchain to see if there anything for me, right? Because I don't know, everything looks very suspicious, but I have to like do all the computing to figure out. Okay, so like someone is sending me like $10, for example. This is very heavy and not useful in the IoT world. So that's why we propose another way of doing this. So the idea is here. So the actual protocol is very complicated, but the idea is simple. So it just means like A and B, they are just like a negotiate a key offline, off chain, and then they will just progress this key to the next version as time goes by. So every time A sends to something to B, like B basically have a different address. However, B can monitor all the addresses very easily because they are all derived in a mathematical way. So you don't have to do all the tedious work to do scanning all the blockchain. Instead, you will just be noticing like the addresses you should be noticing too. So that's the idea, right? I have a diagram here, so I'm trying to be brief. The actual protocol is pretty complicated. So you see, yeah, it's something like this. We have a paper and also implementation, so you guys can take a look at. So I guess like the paper we put into IoTeX.io/academics, you can find the paper and you can find the experiment results within this paper. So I think there are three very good properties that this type of protocol that provides. First, of course, hide the receiver. Second is called forward privacy. That means if someone can compromise the device and obtain a secret for the current transaction, he cannot link to the previous ones, right? And also another thing is called stealth transaction hiding. That means the ephemeral public key only need to be updated every few transactions for two communication pairs. It's like how often you guys want to update the key, it really depends on application. We did the implementation of the Raspberry Pi. It's a very power constrained devices, and we can see like there are a bunch of improvements on top of the existing stealth address protocol. Like you can see, like the sender can just save lots of errors and weightless bytes in order to perform this confidential transaction, as well as the receiver.
So these are bytes.
These are bytes.
Okay.
Yeah. Yeah, so that's all for the tech side. So I want to just cover like a few things that's non-tech because we have lots of people from different backgrounds. So we want to see we have strategic partners. Basically, we are targeting more like the app layer kind of IoT focused projects. For example, Smart Hub is a Paris company, the French company who's doing IoT plus smart home. So they want to build like the blockchain-based solutions on top of IoTeX. So does GSE network in Singapore, Wave in Berlin, and Lenovo is like a wearable company in Seoul. And also, what is this name? I even don't know. XVO in California, probably a new partner I haven't heard about. Yeah. Then here comes the investor. I think that's not the important for us. And here's the core team. Yeah, it's all on the website, so you guys can figure out later. Yeah, so all in all, so that's basically everything we have today. So if you want more information, you can go to IoTeX.io. There's a bunch of information. Also, you can reach me out at Raullen at IoTeX.io, Zhijie at IoTeX.io. And also, if you feel very boring, you can try to solve this mathematic problem. It's quite interesting. Yeah.
There was a question in the chat, is that dual key field address protocol your customized protocol? That this is something that you invented.
I'm sorry, I lost what you're saying.
Was that stealth address protocol your own invention?
No, it has been there. It has been there for a while. But still, we just want to improve that. Because like I said, it's very young, immature. Like every server has to scan the entire blockchain, right? Which is not practical. So we basically like a leap forward, take a big step forward to make it more practical in the IoT use case.
Okay. Any other questions, guys? No, I think we're good.
Okay. Yeah. Or in or like everybody feel free to just like contribute to our code base, like take a look at our website and everything. Just let me know if you have any question, any suggestion, advice, or every business opportunity. We are really appreciate on that. Yeah.
Well, thank you so much for joining us. I think this was super educational and super exciting to see something like that built from scratch, and we are witnessing it just at the beginning. So
yeah.
Thank you very much for sharing.
Okay, thank you, Gregor, and thanks for everyone to attending this class today. Hope you guys enjoy it. Yeah.
Okay, thank you. Bye bye.
All right, bye. I'm Chao Tong.